Hi, good evening, everyone. Thanks for joining this the 7th follow-up training for the winter school, and we'll just get started. My name is Garima Agarwal. I'm one of the co-leaders of the national chapter of the Evaluate Global Movement, Evaluate India, and just before we get started, here are some ground rules. Please name yourself within this format, right? Using first your first name, followed by your last name and your pronouns that you prefer. Right? Here's an example. Please keep your camera and microphone turned off, just to ensure that there is, we get the best quality of audio during the presentation. And all questions will be taken at the end. So you'll have a question answer round at the end, but you are free, please feel free to type them in the chat. And you can reach out to any of the folks mentioned as hosts and co-hosts in case you need any text. So I'd like to have Raisin Gupta join us to give her opening remarks. She is a member of the APIA Community Ownership Evaluation Team, and she's a monitoring and evaluation consultant, many years of experience working in Asia and the Middle East. Please, Rai, over to you.
Thank you so much, Garima, for introducing me, and thank you everyone for joining this follow-up training. As a young and emerging evaluator myself, I feel very privileged to be able to speak with you all and provide the opening remarks for today's session. And because with keeping time in mind, I've kept my remarks rather short. But what I wanted to share is the relevance of such a training in the life of many of us who are working in the evaluation space. Some of us are young and emerging evaluators, others are in the mid-career space, and some of us may just be starting our evaluation journeys. And at the time that I was beginning my evaluation journey as a monitoring and evaluation consultant, I think two of the things I lacked was, one, I lacked awareness about opportunities in the field, and two, even if I did know of opportunities in the field, I lacked awareness of the capacity or the skills that I would need to access those opportunities. So at one level, it was the lack of awareness about opportunities. At the second, it was the lack of capacity. And I believe that events or trainings and refresher courses such as this help to plug both those gaps, which I faced maybe a few years back when I was starting my journey. I think it's extremely relevant that we are all gathering here together to have such a refresher training with such eminent researchers and evaluation specialists from across the world. This is such a wonderful opportunity for all of us to learn from each other, to develop a very participatory and consultative approach, not only in the evaluations we deliver, but also in the classroom that we have on this virtual space today. And we have a fantastic lineup of people speaking after this. And at the same time, I think it's also very important because as we grow in the evaluation space as evaluators, we also carry with us the opportunity to cascade these learnings to others as well. And I think that's equally significant as we move forward. So thank you so much for joining this wonderful session, which I know will prove to be very, very productive for all of us. It's a refresher training. It's an opportunity to learn from others across the world who bring such diverse and unique perspectives on evaluations, on technical aspects, which may be difficult to understand at a very technical level, but maybe easier to understand through examples from across the world. It's an opportunity to delve deeper into stuff that you may not have learned the first time around or may want to learn more about. It's an opportunity to give rise to your curiosity as evaluators and to keep upskilling, which is so very important. And at some level, it's an opportunity to close gaps and democratize access to evaluation space, which is a very wonderful and noble thing that we're all engaged in doing today. So thanks a lot for joining in. I'm sure it'll be a very productive session. And I pass the mic back to Garima for the next steps. Thank you.
Thanks, Rai, for these very encouraging opening remarks and motivating all our participants.
Thank you.
wherever we may be in our career. And before we take the session forward, I'll just the training objectives of today's refresher. Enhance knowledge and skills in integrating data science applications in the practice of evaluation presentation, and to strengthen the evaluation networks in the Asia Pacific, and to connect young and emerging evaluators with more experienced evaluators. And you'll see that speaker today comes with a very valuable experience. And I will just introduce, so our speaker today is Jos Vasan, and he will be talking about opportunities and challenges when integrating data science applications in the practice of evaluation presentation. He is currently an evaluation advisor at the World Bank's Independent Evaluation Group, and has been in this field for a long time, and both as someone in practice and someone who has been training and helping build capacity for others. So I'd like to invite Jos Vasan to give his presentation now. Over to you.
Many thanks, Garima. And it's very nice to meet you all, esteemed colleagues. Let me just start by sharing my slides. I trust you can see my slides now.
Yes, they're visible.
All right, excellent. So it's a real pleasure for me to be here, and I look forward to a discussion on this very interesting topic, which is new to us in many ways. It's about opportunities and challenges for integrating data science applications in the practice of evaluation. And there has been a lot of buzz around this topic of data science, and particularly a subfield AI, artificial intelligence. We have all been following the discussions on the potential and also the dangers of ChatGPT. But the reality is actually that data science applications, including AI applications, have been around for quite a bit longer than ChatGPT. And we're talking about a gradual evolution of the integration of this type of work especially over the last 5 years or so. So I'm going to talk a little bit about the experience of the independent evaluation group in terms of experimenting with data science applications, what we have learned, some of the potential, some of the challenges, and how to go forward. In no way am I pretending to be fully comprehensive. I will talk mostly from the experience of the independent evaluation group. And I think as one of the early adopters of data science applications and evaluation, and also as one of the evaluation functions which probably have been at the forefront of this work, we have some interesting lessons to share. While I'm going through my presentation, feel free to input any questions in the chat. I look forward to taking up these questions after we finish, and I look forward to an interesting conversation on this. So, what are we really talking about? Data science. It's a relatively new field. It's an emergent field, an interdisciplinary field that brings together statistics, mathematics, computer science, and has led to a number of applications that allow us to analyze structured or unstructured big data. So huge amounts of textual data, imagery data, financial data, and other types of data. So it is also quite broad in its applications. It includes, for example, fairly straightforward and uncomplicated text analytics, but it also includes much more sophisticated approaches such as machine learning or even deep learning algorithms. So just to give you a few definitions so we're all on the same page. So machine learning is basically the use of specific algorithms that help us classify content, whether this is text or images or other types of data. And one example is the classification of, from existing evidence, different factors that would be explaining project performance. So you can do this in different ways. You can classify content inductively. So you can look, for example, have algorithms looking at the salience of particular words or the clustering of words. And on the basis of that, you try to identify meaningful categories. This is an area of work which is often referred to as unsupervised learning. But what we mostly use is supervised learning. And this is really an approach where we develop ex ante a conceptual framework, which we then subsequently translate into a taxonomy of words, for example. And then we train an algorithm in an iterative manner to classify samples of, for example, text according to that framework. And in each iteration, we compare the manually validated categorization with the computer-generated categorization. And at some point, we may be satisfied that the algorithm accurately predicts the classification of content that we have been manually also classifying. And at that moment, we can unleash the algorithm onto a really large data set, a data set of thousands or hundreds of thousands of documents or text fragments, data sets that are so large that we cannot possibly cover manually. So that's in a nutshell the principle of machine learning. Deep learning is even more complicated, and it's basically a process where you connect algorithms to other algorithms. So algorithms learn from each other. And we will go into explaining some of these applications. So data science applications have been becoming more widely applied because of multiple reasons. Some of these reasons are an exponential growth in data, big data, textual data in the realm of the internet, social media, websites, imagery data, satellite imagery data, but also video imagery, YouTube, etc., phone data, financial transaction data, etc. And they are now becoming available to us for further analysis using data science applications. Another factor which has enabled the rise in data science applications is the advances in computational capacities. So now we can really manage and analyze large quantities of data, enormous quantities of data, millions of observations that we were previously unable to. And finally, there's also been an increase in the availability of the right expertise, which we now call data scientists, who have knowledge of programming languages like R or Python, and they also have knowledge of data science algorithms, so machine learning algorithms or deep learning algorithms that can help us analyze big data. Now, in the practice of IAG, we have found that data science is promising. It's not a silver bullet. There are many challenges, but we have also discovered that there is a potential that can be further realized. So there are basically 3 points that point at the potential for data science applications. First of all, is the aspect of efficiency. We are now able to delve into and extract content from thousands or even hundreds of thousands of project-related documents in a fairly efficient manner, something that we were not able to do manually beforehand. Another potential lies in accuracy or validity of the findings. If you train a machine learning algorithm well, so you have a well-defined conceptual framework, it aligns well, if we're talking about text data, to a taxonomy of words that you use to search for patterns in the data. And if you train the algorithm well with iteratively verifying manually categorized data with predictions of the algorithm, and then you unleash the algorithm onto the population, then an algorithm can more accurately code and extract meaning from large bodies of data than a human being can. And we have done experiments on that to substantiate this. But of course, it can also go wrong if the algorithm is not well trained, if the conceptual framework is not clear, if the keywords are not matching the conceptual framework. So it's not automatically potential that is realized. And then finally, there's also the breadth of analysis. The number of questions that we can now answer using big data opens up a new space of evaluative inquiry. For example, impact evaluations traditionally have been very expensive because of the cost of data collection, survey data collection. Now we can do counterfactual impact evaluation using, for example, remote sensing data as proxies for some of the real life phenomena that we're interested in. And I will talk about this later a bit more. Now in IAG, we primarily use two sources of big data in our evaluative work: text data and imagery data. And I'll talk about text data first. So with text data, I'm talking about internal sources of text, internal to the organization. For example, thousands or hundreds of thousands of project-related documents within a big organization, such as the World Bank Group, but also external data, data that can be found on websites and social media, etc. So text data can be analyzed using simple text analytics, keyword searches, for example, but also much more complex techniques, as I already was explaining, like machine learning-based classification, or even much more complex techniques that also help us to understand meaning in text. And here we are in the realm of the large language models such as ChatGPT. So let me give you some examples of how this works in practice. So a very prominent application of text analysis and machine learning in evaluation is actually in the identification of the evaluant when we talk about complex programs. So say you're interested in understanding an organization's relevance or an organization's effectiveness in a particular country, on a particular sector. Now, if you're lucky, all the underlying documentation of the interventions that are being financed or being implemented by the organization are well coded and well organized. So you can identify the evaluant fairly easily. But sometimes this is not possible. For example, in the case of IAG, but also in many other organizations, we are asked to say, evaluate, has the World Bank Group been successful in supporting rural electrification? Or has the World Bank Group been successful in helping to combat malnutrition? Now, in such cases, there are no easily available existing codes of project-related documents that can help us put together, okay, this has been the program and this has been the portfolio of work of the organization. We actually need to piece it together. We actually need to do text analysis to understand which bits and pieces of different projects, and in the case of the World Bank Group, this may be thousands of projects over a number of years, have actually been contributing to this particular goal of combating malnutrition. So then we use, for example, classification algorithms to understand to what extent is a particular project and in what way is it related to the objective that we are interested in. And this slide shows you a simple example of how we did this for a particular evaluation that looked into the Doing Business project, which is about reforms in the private sector to promote business, among other things. Another example of text analysis is in the context of program evaluations at the level of the country program. And in this case, we used media analysis to understand public opinion around national and sectoral reforms that were supported by the World Bank Group. So how did we go about this? We went about this in a fairly systematic way, quite systematic way. So we procured a data set, we bought it, it was not that expensive. A data set with more than 300,000 hyperlinks to news articles that relate to the country. These were from international, national, regional, local media. And if you want to do the news analysis, you really have to have such a big data set to really be able to triangulate and to look for patterns. We then used web scraping protocols to basically extract the body and the headlines from these articles into a data set. Basically something that you can do using Python. This led to more than 200,000 articles. There was some attrition due to the nature of the data formats and other factors. And then the next step was, because these media articles were not necessarily in English, we used machine-based translation of these articles, which again led to a new data set. And again, there was a little bit of attrition, but we still had a quite broad and very diverse data set of 141,000 articles. And then we could use that large data set to conduct actually several types of analysis. So we conducted sentiment analysis around particular themes and reforms. And we also reviewed manually text fragments that were extracted by algorithms. So we could look at what is really the public opinion about regarding a particular type of reform, let's say in the energy sector, for example. So as a result of this analysis, we got a better insight regarding the public opinion around many of the bank group supported reforms, including the geospatial distribution of public opinion in the country. So to conclude on text analysis, we have now learned that there are many things that we can do using data science on text that are really helpful in complementing existing evaluative work. And that's the right-hand column of this figure. We can describe the portfolios of projects, we can do media analysis, we can do structured literature reviews, we can look at we can extract the geospatial location of project activities. And these are all activities that we do that complement existing work. On the left-hand column, we see some activities that have really changed because of the use of data science. So the way we now identify the evaluant in large complex evaluations on the World Bank Group's work has really changed. We are now doing this through semi-automated identification using machine learning approaches in a much more, let's say, standardized way. And also the way we do synthesis work, so delving into existing project level and higher level evaluation documents, we now use text analysis and machine learning techniques to extract and classify knowledge in a much more, let's say, routine manner than before. So we can say that these types of activities have really transformed as a result of data science applications. Now, the next type of data that are really making their entry into evaluative work is imagery data. So imagery data are a very powerful source of data. For example, they include decades of publicly available satellite imagery data with global coverage that are available at a reasonable resolution and that are also free of cost. So you can actually use longitudinal global data sets of imagery data. You can use them free of charge. You just need to manipulate and analyze them. And that's where the cost and the complication lies, of course. If you want to have more granular, high resolution satellite imagery data, they are also available, but usually at a cost. So there are also other types of imagery data that we can use. But we can now, with the enhanced computational capacities that we have, we can apply machine learning protocols, for example, to link particular imagery data, pixels, to particular meanings. For example, we can classify pixelized data into land use patterns or the state of buildings, categorization of that. And these variables are often useful proxies for real life phenomena that we're interested in. For example, we know that there is an association between the state of buildings and the geospatial distribution of poverty. And if we can then also verify that link empirically, for example, with survey data, then we know that we have a very good or not so good proxy of poverty using remote sensing data, for example. And that is very powerful in analysis that we want to do subsequently. So how does that then work in practice? We can now answer questions around the relevance and effectiveness of our organization's work in a complementary way using big data, imagery data. For example, what we see in this slide is that we can do a complementary analysis around relevance by using the principle of geospatial data layering, and basically answer the question, is financial support going to where the needs in the countries are the highest? So how does this work in practice? So often we use satellite imagery data to assess the state of dwellings or infrastructure as a proxy for the geospatial distribution of poverty, and then we can create poverty maps using machine learning-based classification. But in this case, we actually used already a publicly available data set on the geospatial distribution of wealth. So this was already available free at cost on the internet, and we compared this distribution with a geospatially disaggregated data set on where World Bank Group financing is going. And this shows a very simple comparison between the number of projects and the incidence of poverty. We use other variables, the amount of funding as well. We also use data from development partners, from the Treasury, etc. But basically the idea is to compare where is the money going versus where are the highest problems. And the lower right graph in this slide shows actually that over time, the bank has become a little bit more, a little bit better at targeting, because more of the support is going to where actually the need is highest. Of course, there are many caveats to such analysis, and that's why we also see this as a complementary analysis. It won't, answer the relevance question in its entirety. Then another example is the effectiveness question, and basically here the objective is to determine did the World Bank Group's support to improving urban infrastructure make a difference? So here what we did is we analyzed the changes in the built-up environment as a proxy for economic activity. And this increase in economic activity may have been caused by improvements in urban infrastructure supported by the bank group. So we classified changes in the built-up environment by using imagery data to get an idea of changes in horizontal, which is basically land use classification, and vertical density. And you can do that with remote sensing data. And then we basically designed a spatial counterfactual design. So we compared changes over time in areas where the improvements took place, were areas with comparable areas where there were no improvements in urban infrastructure. And then we further augmented that with a statistical analysis to also control for other differences between these areas. And that could give us an idea of what could be the added value of urban infrastructure improvements to changing economic activity. As it turns out, in this particular case in Mumbai, which I'm showing because of the, the Asia Pacific, it was too complex to disentangle the causal effects. There were many also causal factors apart from urban infrastructure improvements that were influencing these changes, and we could not unravel that statistically. In another case, in Maputo, we actually could do this much more successfully because the urban infrastructure improvements were much more important as a causal factor, and many other explanatory causal factors like changes in investments, changes in the overall economic environment were much less important in terms of differences between the areas. But this is another interesting potential. So we have now seen some examples of how we could use data science applications in evaluative work. There are many, many more, and some are more useful than others. But we have learned that under the right conditions, they can lead to efficiency gains, they can lead to quality gains, and they also can lead to gains in terms of breadth of analysis. Now, the challenge is that in many institutional environments, in many organizations where you conduct evaluations, there are not necessarily opportunities or resources or incentives to invest in this innovative work. So you really have to show that these investments in innovation make a difference. So what could an innovation strategy look like? First of all, you need to think very clearly about, okay, where is it, in what types of evaluations can we do meaningful big data analysis that can really help answer important questions. Then you design the application, which should involve a very good collaboration between data science experts and evaluators. Then you conduct the analysis and deliver a product that is really attuned to the topic. You review, how did it go? How useful was it? Did it really add value to answer the evaluative question? And then you derive conclusions. Is this something that we should do more? Does it really lead to efficiency and quality gains? Or is this something that may be useful, but not in many cases? Or is this something that in terms of cost benefit is not worthwhile investing in? So that is what we try to do more or less with the different experiments that we are doing. And some of these experiments, frankly, quite dramatically or not dramatically failed, while others succeeded. So some conclusions. First of all, let me assure you that data science is not going to revolutionize evaluative work. Evaluation is first and foremost critical qualitative inquiry supported by many, many different types of methods and many types of data, qualitative and quantitative. We also know that data science has a place. It's not a fad, but it's certainly also not a silver bullet. So we have found that there are many biases, but we also know that the potential is sufficiently high for us to take notice and really conclude that, you know, we really need to be in this space. And we really have to make informed choices about how we are going to use and integrate data science applications in our work. So going forward, what are some of the issues? And what are some of the potential challenges? So first of all, I already discussed that some data science applications may actually have what I would call transformative potential. So they really will change the way we do things. For example, in complex evaluations, in some organizations, and national governments, UN, multilateral development banks may be in that situation. In complex evaluations, we may change the way we identify areas of work under big global or regional or national themes. Evaluative synthesis is also something that probably will change. But most data science applications are probably complementary. They are not going to change the way we do evaluative analysis, but they will complement, they will add value, they will add another another empirical component to the research which help us to strengthen the validity of our findings. The second important point is that we may actually fall into the trap of data-driven work. With all these data becoming available, we have to resist the temptation just to go out there and analyze. You know, computational capacity, human expertise, data acquisition and manipulation is expensive and may divert us from the real priority work that needs to be done. So first and foremost, we need to focus on what are the questions that need to be answered on an evaluation, what are the hypotheses that need to be tested, what data can we use, and within that, what role can big data analysis play? So it should be a question-driven analysis and not a data-driven analysis. So always, first and foremost, evaluation design is important. A third important point is that when we use big data, whether it's text or whether it's imagery or other sources, we need to be aware of the biases. So to what extent is the data that we are analyzing a good representation of the phenomena that we're interested in? And let me give you two examples. In our use of text data, for example, we use a lot of information from project documents, thousands of project documents. However, we know that many of these project documents are written with inherent biases because our operations colleagues are not going to write down certain things around unintended effects or certain sensitive issues. So we know that these issues are missing from these documents, and no type of analysis can correct for these inherent biases. So you have to be aware of what is in the data, what is not, or to what extent your primary data are distorted or not. Then on imagery data, it is very attractive to use remote sensing proxies for, let's say, estimating changes in land use or estimating changes in poverty levels, which you can then use for your relevance or effectiveness analysis work. But you need to understand, first of all, whether the proxy is a good proxy for the phenomena that you're interested in. So you need to know how is it associated with other data that tell us something about the phenomenon. You need to also be on the ground to understand what does the phenomenon really mean. If you're interested in poverty alleviation or changes in economic activity, what does that really mean in that particular context? What are the factors that influence it? What other data do I need to collect if I want to develop a causal contribution story about how an intervention changes this phenomenon? So big data analysis does not substitute in any way good work on the ground. You need good work on the ground to be able to assess how useful your big data analysis can be as a proxy analysis regarding the phenomenon that you're interested in. Then my fourth point, I already talked a little bit about incentives and opportunities for innovation. It is important that we convince our management around the efficiency, the quality gains, and the potential gains in breadth of analysis, so we can create a space in evaluative work to do big data analysis. That's not always easy, but first and foremost, we need to also show the evaluation users, the decision makers, and other stakeholders that use evaluations that big data applications can really add value to understanding the relevance and effectiveness of policy interventions. If we cannot show that potential, we cannot innovate. We cannot just innovate for innovation's sake. And finally, if you want to successfully use data science applications, if you want to successfully integrate them in your work, you need to have certain levels of data science literacy. You probably would want to hire a specialized data scientist. You probably would want to have in your team or among your consultants analysts who have some understanding of data science applications, not necessarily specialists. And most importantly, you need to have evaluators and evaluation team leaders who understand what it is about and when and under what circumstances it makes sense to use particular data science applications like machine learning models, because there are certain rules and circumstances that determine when they can be useful and when they are not useful. So with these lessons learned, let me stop here and thank you very much for your attention. Over to you, Garima.
Thank you so much, Jos, for that presentation. And I loved how you started your sort of key takeaways, and that data science applications will be complementary in most cases. And so I think that's a big takeaway in terms of how it'll be just one of the other methods that we continue to employ. Right. So thank you so much. And participants, please feel free to start sharing your questions in the chat. And I will just take a second to share my slides. I hope my screen is visible again. All right. So just to get started, just you were talking about how in these sort of experiments, you have sort of found some cases which you felt, right, the kind of information that you were seeking, there was a failure, or in some there were, right, there was a success. So I just wanted to ask you if you could share with us an example of one of those cases where the data science application sort of changed the way or augmented how you saw that the findings of that impact evaluation.
Thank you, Karima. So a case, let me talk about one case where what I would call a failure, but not a failure in the sense of a wasted investment, but a failure in terms of utility for the evaluation at hand, which was low, but utility for us learning about how to do things better, very high. So we had early on, a few years ago, we had an experience of working with a very experienced firm, which promised us to do advanced content analysis using machine learning techniques on a portfolio of projects. And they promised us also, we bring in not just data science expertise, we also bring in evaluation expertise. So we commissioned this piece of work, but then we realized early on that this was going really, really wrong. And the reason why was that in the analysis of the data, there was no real conversation going on between people who understood the organization and the subject and the data science work. And even though the company had evaluation expertise, these esteemed colleagues were not really knowledgeable of how the organization worked and really the content of the interventions. So there was a mismatch in the dialogue between substantive expertise and data science expertise. So a lot of fancy things were done, but they were fairly meaningless. So one of the most important lessons that we got from that exercise is that you really cannot have data scientists working alone. And you really need to have a very close interaction all throughout the process between subject matter specialist and the evaluation specialist and the data science expert. So now we are fortunate to have in-house data science expertise, and these colleagues also have learned a lot about the organization and the subject. So they already have a basic good understanding of what makes sense and what not, but they also collaborate much more intensely with our evaluation colleagues, and that really leads to much more successful outcomes. So the successful experiments were really the ones where we made the right decision regarding, okay, does it make sense here to use a data science algorithm to extract information, or is it more efficient and is it better to just manually read the documents? Because you need a certain sample size and you need a certain level of clarity and training time for a machine learning algorithm to work. And that's a big investment. So in some cases that investment is worthwhile, in some cases it is not. So we are getting better at knowing when to use it and when to not use it. And when we use it, we probably are getting better at doing it well because the data scientist is talking with the evaluator constantly. Sorry, that was an elaborate response. I hope that was clear.
Yes, thank you so much for that. That is, I think, very helpful to think about, right? There's the communication between all experts, the data scientists, evaluators, and sub-program staff and subject matter experts. All of that is extremely important. Thank you for that. I want to encourage participants to please post your questions in the chat or raise your hand so we can, we have Josie for another 15 minutes to answer your questions. So then I will ask some of mine. So one of the things you were mentioning was that sometimes, right, and this was in the case you had shared about relevance, right? That big data may not always be able to answer that question of relevance. And how do we pair big data with the efforts that are ongoing or other, what one might consider more traditional methods to ensure that we are really getting better results from sort of the combination of these methods?
Thank you, Garima. I see that there are some questions in the chat now, but let me answer your question first. So regarding relevance, so you can look at relevance from multiple angles, right? So you can ask the question, is the intervention or is the organization addressing the right needs or priorities in a particular region or country? Or is the work that is being done in line with the objectives that we set out to achieve, or in a strategy or so? Or is what the organizational intervention doing doesn't make sense given the problems and given what others are doing? So you can frame the relevance question in multiple ways. Now, in many of these ways, big data analysis can be useful. For example, I already gave the example of geospatial targeting, which is in a way the question: are the resources flowing to the places where, let's say, the needs are highest? Of course, there are many drawbacks to that type of analysis, because you cannot disaggregate the data to very granular levels when it comes to where the organization's funds go, for example. And you also need to understand, what is being done versus what are the exact needs. All of these questions you cannot answer with big data analysis. So you need to augment it with qualitative analysis. But another example of big data analysis would be text analysis. So you can, for example, analyze, you can have data on or studies on what are the big challenges in the energy sector or the agriculture sector in a particular country, and then you can analyze your portfolio. To what extent have there been activities financed or activities implemented that are addressing these concerns? You can use text analysis to do that. Not necessarily very sophisticated text analysis, because the samples of projects will be probably smaller, but you can still do this in a data savvy way, for example. Over to you.
Thank you for that. I'm going to take up one of these questions that from the participants. This is from Praveen Shrestha. What ethical considerations related to data are vital in the use of data science in evaluations?
Yeah, that's very important, because first of all, you may be tapping into proprietary data. So you may be, if you're looking at private sector operations, for example, there may be confidential data that you're looking into. So you have to be sure that the data is treated carefully and that no confidential data is being shared. When you are looking at, for example, health system, and you are looking at, you're trying to delve into what are salient issues in patients' experience in health centers across the country, you can do text analysis on that. But again, you have to be, very careful that you are responsibly using these data. So you probably will want to submit your proposal to a review committee that you're saying you're going to use patient data, patient experience data in a big data experiment. And you don't want to publish any data that can be traced back to particular persons, and certainly not share any confidential data. So you have to be very clear about what are the ground rules around responsible use of data and data privacy that can come up also in big data exercises. So ethics is a very important topic here. The same goes when you're using mobile phone data. For example, mobile phone data have been used to track patterns of migration of groups when there is a crisis in the country. Well, these are personal data. You cannot just use them and look into them. So you have to have protocols and rules in place for the responsible use of those data. I hope that answers your question.
Yes. Thank you. And Praveen, if there's a follow-up, please feel free to type it in. And yes, I think as there are developments in how we, regulations around data use, data governance, but I think it's a very interesting place for us to see where our own sort of ethics and principles from within the evaluation field, how do those play alongside those, and how do we maybe even take them further. Another participant, Kasoon, sort of has chimed in with this sort of similar sentiment. I'm going to read Babita's question. She has asked, what type of data can be used in parliamentary research? Babita, would you like to clarify that question a little further? You can please unmute and go ahead.
Hello, good evening. I'm Babita Mishra from Nepal, and I would like to thank you for your wonderful presentation. And I would like to, some query. My query is, I belong to the parliament. That's why we are doing one type of research, because there are a lot of reports, So I want to know, how can we use, what type of data can we use in our report? I just want that.
Thank you very much, Babita, for your question. So there are experiences where parliaments have parliamentary units that have an M&E function, or there are ministries that report directly, ministerial evaluation functions that report directly to Parliament. So in Parliament, you need to have very, very clear answers to big strategic questions, among other things. So you need synthetic evidence. So I can foresee that evaluation functions that report to Parliament need to be very good in terms of synthesis. And evaluative synthesis has been evolving as a field. And one of the innovations in evaluative synthesis is the use of scraping protocols, is the use of text analysis and classification algorithms to basically try to classify and subsequently manually interrogate large bodies of text. So, for example, at IAG, we can now look into thousands of self-evaluation documents in a very efficient way if we want to understand, okay, what are, let's say, the biggest implementation challenges in projects in a particular region. This analysis we can partly semi-automatized because we can develop a simple conceptual framework of what we think are major implementation challenges. And then we can train an algorithm to extract information from these large bodies of document to classify, to extract and classify pieces of text around these factors. And then we can develop descriptive statistics, or we can manually read these different fragments to develop a qualitative synthesis document of what we think are some of the major issues that influence project performance. So I can imagine that a parliamentary unit that a parliament will benefit from synthetic evaluation knowledge, which in part relies on, let's say, text analysis and machine learning protocols to synthesize evidence from large bodies of text. Over to you, Garima.
Thank you,
I hope
sir.
that answers.
Great. Thank you so much, Joss, for this wonderful presentation. Since we're close on time, I wanted to ask you if you have any closing remarks or key takeaways that you would like today's participants to leave with. And any participants whose questions we've missed, you can email the Winter School team, and I'm sure they'll be able to get them to Joss.
So, I don't know. Was there another question, Garima?
Yes. So I was just asking if there is, we can take another question, or we can, if there's any key takeaways that you would want to reiterate. But if you like, we can take another question.
Yeah. Well, just one thing from my side, I wanted to reinforce two important messages. One is that I hope that you will welcome the use of big data and analytics in your evaluative work, but also give it its proper place, in the sense that proper research design is important. Proper systematic thinking around purpose, scope, evaluation questions, and the connection to methods and data is important. And then comes the potential for data science applications. That logic is very important. And the second point that I wanted to make, when I was at university, what was upcoming then was multivariate statistical analysis, regression analysis, etc. We suddenly were able to do this using computer packages like SPSS. I still programmed SPSS by hand, and later on in Fortran, later came the menu-based statistical program. So universities already trained us to use multivariate statistics, and now there are, it's really common that graduates understand, multivariate statistical analysis and econometrics, and they use it in professional practice. Something similar is already happening in data science. So we see that more and more younger people are graduating from university, and they have an understanding already of text analytics. They already have an understanding of manipulating imagery data. So they already understand, the basics of Python and R. So this is very important that young people have these competencies, because young and emerging evaluators, analysts, they will be the ones, you will be the ones who will drive a lot of this innovation going forward. So I encourage you to show an interest in this topic if you have not done so already, because you are very important to the evaluation field. Over to you again, Garima.
Thank you so much for those final takeaways and the encouragement to all of us here. Before we close, I'd like to ask all of you to please turn on your camera so we can take a group picture together.
Everyone put your camera on. Madhuka, over to you.
Yes, hope everyone, if you are able, please turn on your camera. And Okay, I'll count 3 and try to get a photo, and please have a smile on face. Okay, 1, 2, 3. Here we go. Please stay one moment. Okay, thank you everyone.
Thank you, Madhuka. And thank you again, Joss, for today's presentation. I think you've given us a lot to think about, and thank you again for the encouragement. I'd like to now invite Van Nurul Hamini, who is a co-leader of Evaluate Malaysia, to give closing remarks.
All right. Thanks, Rima. I hope everyone can hear me well. Please excuse me because I'm a little bit under the weather, but it has been a wonderful evening learning from Joss and the question that you have posed. And actually, my personal key takeaways from Joss sharing basically evaluation evolves along the diversity and the increasing volume of data and the computational power that enables data science. And also we need to balance, right, between the potentials and the flaws of data science. Hence, Joss said, we have to innovate thoughtfully and responsibly for evaluation, make sure that there's proper research design in place. And I can also resonate with the challenges to embed data science in evaluation process, because there's much thought need to be put into planning and research. So all the tools and processes are fit for purpose. And, as evaluators, we always need to do self-reflection, right? So make sure that we document all the experiments and the lessons learned from using, new tools like AI. I also would like to thank Joss because he keep reminding us that, we ought to be aware of our own biases in each step of data, whether it's a collection, selection, analysis. And if you allow me to actually express the most striking part in this evening discourse, actually, as a young and emerging evaluator, actually most of us are digital natives. We are able to use data science as our greatest advantage. But as maybe Spider-Man said, with power comes responsibility. And at this juncture, I would like to thank, maybe express our collective gratitude to Joss for his excellent sharing, for Garima for great moderation, for Rai for encouraging opening remarks just now, and of course for the organizing team, and also for all the participants. And truly learning never stop for us evaluators. And as I understand, the 8th refresher training will be coming up soon, right, Randika? So I leave you all with the wisdom of one of the greatest statisticians, or I call him the greatest data scientist, as he managed to communicate data in such a beautiful way. I'm a huge fan of the late Hans Rosling. And then he said, the world cannot be understood without numbers, and it cannot be understood with numbers alone. Right. Thank you so much.
Thank you very
so
much.
Thanks again, everybody, for attending, and thank you to all our speakers. The 8th follow-up training is coming up. Thank you, Van. And it will be on the 27th of September. And it will be on qualitative interviews for evaluation studies, right? So yes, we must balance all our methods. And also information, here's some information on the 4th, sorry about this, yes. 4th APIA conference, which this year will be held between the 4th and 7th of December in Manila, Philippines. Applications and interest for participation, if you can, this is now open. The theme this year is the future evaluation, leveraging partnerships for equitable development in Asia. So hope some of you can join us. All right, thank you everyone again for this wonderful opportunity to learn. And we'll see you next time.
Thank you.
Thank you.
Thank you.
all.
Thank you for the excellent organization. and for the invitation. And thank you for
Thank
the
you.
session.